Uh, Welcome back, members, to our YouTube channel. It's still Math in Motion, Shaka Anwar, the math tutor. Today, let us do the second part of our Markov chains. And as we agreed that last time we stopped on example 2, today let us complete the examples I had for you. Our third example is about weather forecasting. Now, today, our example is saying that the probability of raining on a particular day is 0.1. The probability of raining the following day given rain on the previous day is 0.4, and the probability of non-raining in the non-raining, so I've done so non-raining, this is not there, non-raining the following day, given non-raining in the previous day is 0.7. Then construct a transitional probability matrix, and then construct a transitional probability curve. From this we know that they want us to, they have given us the probability of raining. Okay, our states, remember we said we shall always first define our states. Our states are, we have state 1 of raining and then non-raining. Now, to make things easier, we have to attach numbers to these states. Like I may say that for state 1 is going to be 1 for raining, and there's going to be 2 for non-raining. Therefore, I'll have states as 1 and 2. Now, they said the probability of raining in a particular day is 0.1. So the probability of raining, probability of raining in a particular day is 0.1. Therefore, the probability of not raining in a particular day is 0.9. Just from that statement, they say now, the probability of raining the following day, the probability of raining on the following day, even the previous day, even raining on the previous day is 0.4. They mean that the probability of one raining the previous day given raining the following day is 0.4. Therefore, the probability of raining the previous day given it did not rain the second day is 0.6. We say that we shall need to submit the whole row to equaling to 1. Therefore, if I say 1 minus 0.5 of 0.6 here. Now the other question is saying, and the probability of not raining the following day given not raining the previous day. So the probability of not raining the previous day given not raining the following day is 0.7. Therefore, the probability of not raining the previous day given raining the probability of not raining the previous day given raining on the next day is going to be 0.3. Now from here I can easily get my transitional probability matrix as Pij. As I said, Pij is the same thing as having remember here I have P11 is going to be here 0.4, and then P12 is going to be here as 0.6, and then lastly I want to have 0.3 here and then 0.7 here. We say that if we add the row, we have to get 1. Therefore, my matrix is that. And then transition diagram, we just say that we have just do our states. You have state 1, then state 2. Yes. This one is state 2. Now, what we do here is that we shall always, now we say the probability of me staying at step 1, 1 to 1 is going to be 0.4. Now I'm coming from 1 to 2. I'm coming from 1 to 2. It's going to be 0.6. Now I'm coming from 2 to 1. 2 to 1 is going to be 0.3. And then 2 to 2 is going to be 0.7. And I'm done with that diagram. I think this is the thing you saw last time in our previous examples. And just note that for the other steps we're going to do, so I'll majorly talk about this example of forecast to get to know what I want to talk about. And therefore, I think you should just need to note where this transition probability Pij 0.5, 0.10, 0.7, 0.7 somewhere, because our next subheadings are going to be majorly, we shall majorly use this example of the weather forecasting. Okay. Yes, members, now let us continue with our second subheading, that probability of a pass. Here, if given a particular Markov model, the probability of a particular sequence of future states can be estimated using the probability of a path. As in, here I want to know, given an example, we want to know that in the 50th day, if it will rain, given the 4th day it rain, given, okay, you're given like a sequence, you're given like information about different days. Like on the 50th day, it's going to rain. On the 4th day, it's going to rain. Okay, they want to find the probability of that sequence given to you. Like our example here, we have an example. Let's talk about forecasting. Now here for forecasting, we're saying that we want to know the probability that on the 50th day, it's going to rain. Given going to rain on the fourth day, it's going to rain. On the third day, it's not going to rain. On the second day, it's going to rain. On the first day, it's going to rain, and then on the next day, it's going to rain. Okay, we're given a path to follow. How do we go with that the probability of a given path? Now here we need to know that we have two cases. The first case is when we are given just a path with no condition, and then given a path with a condition. Like here, I'm saying that here the probability of x5, x4, x3, x2, x1, but we are given x0 as a condition. Now here we just do like this. Remember, we said that this we are talking about Markov chains. Now for example one, remember, for example one, we say that a Markov chain it helps us understand the future depending on the present, but not the past. Therefore, we shall always multiply. We shall always determine the future using the present, not the past. Therefore, this whole thing, the upper thing, the same thing as having times probability of x5 equal to 1, provided the current state x4 equal to 1. Now times the probability of, now as we say that if you have, okay, let me first give an example that if you have like Monday, Tuesday, Wednesday, Thursday, and then Friday. Now, if we want to predict what will happen on Friday, shall always depend on what happened on Thursday. Therefore, Friday is the future of Thursday, and Thursday is the present. Likewise, this Thursday is going to be the future of Wednesday, because if I want to know what happened on Thursday, I always depend on what happened on Wednesday, not Tuesday or Monday. Therefore, also Wednesday is going to be the future of Tuesday, but remember Wednesday was the present of Thursday. Therefore, we shall always depend on the current to determine the future. Therefore, I have to ignore all the past on a particular sequence. Like I'm saying that if we want to know what will happen on Friday, on the fifth day, I just depend on what happened on the fourth day. And then if I want to know what happened on the fourth day, equal to 1, I'll just know what happened on the third day. Then if I want to know what happened on the third day, times probability of x equal to 3, equal to 2. I just need to know what happened on the second day. And then if I need to know what happened on the second day, like that, equal to 2, I just need to know, okay, so it is 1. I just need what happened on the first day, equal to 2. Then times if I need to know what happened on the first day, x1 equal to x1 equal to, it's going to be equal to 1. Now I just need to know what happened on the initial day, which is 1. But now I'm saying if we have no condition on our path, like this example 1, we just need to multiply times the probability of x0 equal to 1, like that. Now from here, I just need to know how the states are transiting. Like I'm transiting from state 1 to state 1. I'm raining. 1 to 1 is 0.4. I think you are seeing what I'm saying now. My answers here are going to be 0. I'm coming from 1 to 1. The probability of 0 from 1 coming 1 to 1 is 0.4 from our probability matrix, which we have here, Pij. Here now I'm coming from 2. The future is 2. So the current is 2. The future is 1. I'm coming from 2 to 1. 2 to 1 is 0.3. 2 to 1 is 0.3 times 0.3. Now here I'm coming from 1 to 2. We don't consider this x2 and x3. X2 is telling us that the current is x2, the future is x3. But now what would happen in the current is 1, and then what happened in the future is going to be 2. Therefore, here I'm coming from 1 to 2. 1 to 2 is 0.6 times 0.6, and then I'm coming from 2 to 1 again, 0.3. And then lastly, not last, I'm coming from 1 to 1, which is 0.4. Yes, 1 to 1 is 0.4. And then lastly, times the probability of x not equal to 1. The probability of raining is going to be times 0.1. If you're not given this probability, we just ignore it and just leave it times probability of x not equal to 1. I think we are together on that step. Now, for the other question is when we are given a condition like like this second example here. If we're given a condition like probability of x5, x4, x3, x1, x2, x1 given x not equal to 0, we just do the same thing, but we just ignore this last part. We just ignore this probability of x equaling to 1. I just stop from here, and then also at the end I just ignore this last part here. I'm coming again. I'm saying that if you are given a condition, we want to multiply times the probability of the last part. If you're not given a condition, we have to multiply times the probability of x not equal to 1. And then that probability, if it is not given in the question, we just leave it like times probability of x not equal to 1. But now for us, our question was given a probability of raining is 0.9. We of not raining is 0.9. Is 0. So 0.1 then 0.9. That's why we multiply that times 0.1 here down. I think with that, you can easily answer all questions. Let us first appreciate this. At the end, you shall do a question combining what we have been doing, and you see that what I'm trying to tell you is simpler and easy. Yes. Now let's go to the next step. Yes. Now, members, let us continue with another subheading: the end step transition probability. Members, recall that we had our PIJ, transition probability. Our PIJ, it was dealing with the present. It was dealing with the future given the present, and the time difference was only 1. As in, the time difference between the future and the present was only 1. Here you see that xn plus 1 and then xn. The difference between xn plus 1 and n is only 1. Here we're talking about just the time difference between the future and the present. So the future and the present is 1. But now we shall always now need to know what will happen if we have n difference between the future and the present. Like someone may ask you a question that what's the probability that it will rain on Friday given it rained on Monday? You have not been given a path to pass through. You have not given that on Monday it will going to rain, Tuesday, as we had an example before. But now here we want to see you're not given a path to pass through, as you're not given different states in different time intervals. How are we going to do about that? Like I'm saying that our n step transition probability Pij is going to be Pij. I may be having xn, I may be having the future probability of xn, but I don't know this n given the future. So given the present, x naught is I. I'm saying that we want to know the probability of having the future given the present, but the distance between the present and the past, so the present and the future is there are n steps. In what this Pijn is the same thing as having that's why here I have just put here one. I'm saying that this one means that there are n steps, there are 1 steps between the future and the present. Yes. Now if I put here n, means that there are n steps between the future and the present, and then Pij can also be written as Rij power n. If you see Pij or Rij n, just means the same. Okay, I've said in what this means that the probability of the state after any periods will be J given the current state I. I think I'm trying to make sense of this. And then this will help us answer questions like what's the probability that on the second day it will rain given on the initial day it will not rain. Like our good example is here. Like find the probability that on x2 on the second day it will rain given on the initial day it will not rain. As you see this example here, we want to give it what will happen on the first day, like x2. What's what happened on x1? We don't know what is happening on x1, but they want us to get the probability of this the second day given the initial day. There is a step which is missing, and therefore the step is going to be 2 minus 0, which is 2. Therefore, this is now going to be our Pij 2 here. I'm making sense. Now, in order for us to answer this question, I want us to go through these various steps for us to answer this given question. Now, for us to let's answer this question now. I think let me put off this first. Now, our question is that we will find the probability of x2 equal to 1 given x naught is 2. Now, for this here, we shall just do the same thing. Now, this is the same thing as having. Remember, we say that these are Markov chains. The future depends on the present, not the past. Therefore, this is the same thing as having the probability, yes, probability of now x2 equaling to 1, given the present is what has to be x1. But we don't know what's x1. X1, it may either take raining or not raining. Therefore, I'll have to have two. This is the same thing as I have to have 2x1. Therefore, this is the same thing as having probability of x2 again equaling to 1, given x1 equaling to. It may either be 1, it may rain or not rain. Yes? Then also, our past is going to be x0 equaling to 2. And our past is going to be x0 equaling to 2. But we say this is not how we define a Markov chain. By us knowing this tells us that we shall always forget about the past. Therefore, there is no need of us writing up again this x not equaling to 2. I just say that x not equaling to 2. I just stop here. I close my bracket like this. Then here like this. Now, times now. What is going to happen on x1 is going to depend on what happened on x0. Given x0 equaling to 2. Yes, times now probability now of x1. X1 is what? Is 1. So the x1 is 2. Here it's going to be either 1 or 2. Yes? X1 can rain or not rain. And then here's going to be x1 equaling to 2, given x0 equaling to 2. Then I have to add both of these ones. Or am I making sense of what I'm doing here? I'm saying that for us to know what happened, the probability of x2 given x0, I'll first need to know what will happen on x1. On this x, because now the immediate number before x2 is x1. Therefore, I'll use a Markov chain and say that I'll need to know what happens on x1 before I know x0. Therefore, this x0 is the past, and then x1 is the current. So it's the present. Yes. Now, for me to know, now this is the same thing as having probability of x2 equaling to x1, given x1. X1 can take on values raining and non-raining. That's why I've convert these two probabilities. Now, but also x1 follows the Markov chain that for me to know what happens on x1, I just know what happens on the initial day, which is x2, like this. Now, for here, I can easily get the answer. I know that probability of I'm transiting from 1 to 1, which is 0.4, so that this is 0.4. Let me write it this side here. This is the same as having 0.4. I'm coming from 1 to 1, then 2 to 1. 2 to 1 is 0.3, like this, then plus. Now I'm coming from 2 to 1 is 0.3 times then 2 to 2, which is 0.7. Now from here I can easily get my answer as 0.33. Now from there, now a good thing now we've got our answer as 0.33 of the probability of x. This is 0.33. Now let us go on. Let me first show you something. I want to combine these two. Now we are saying that since I have an addition sign here, it's the same as having summation. Yes. Now remember, we have two states. We have a state of raining and not raining. Therefore, our x1 can take on either 1 or 2. Therefore, I'm going to say k equaling to 1 or 2. Now here I'm going to have now probability of x2 equaling to 1. I'm saying x2 is 1. But now this one is changing. It is either 1 or 2. Given x1 equaling to k. Am I making sense? I'm saying that k, my k here, because k is changing from 1 to 2. Therefore, my k can take on values as 1 and 2. Now, if k is 1, I'll have probability of x2 equaling to 1. Then k, x1 equaling to 1 when k is 1. Then when k is 2, I'll just have this second part here. Now, times probability now of now. I'm seeing x1 also here changes. I have probability of x1 equaling to either k. It has to be k. X1 is equaling to k because it is either 1 or 2. But now probability of x0 is constant. X0 is 2. Now from here, I just need to write now. I just simplify it into my Pij. Now this is the same thing as having summation from k equaling to 1, then 2. Now since I'm transiting from k to 1, this thing I can just write it as p k then 1, like this. Now times the probability now of I'm coming from 2 to k. 2, then k. And then since time periods are 1 in between 2 and 1, I just put here 1 and 1. And then this is just meaningless. Now this will just simplify that. I'll have, if k is 1, I'll have p 1 1 times p 2 1. Now plus, when k is 2, I'll have p 2 1 times p 2 2. And then p11 we say p11 is 0.4 times p21 is 0.3, and then plus p21 is what? p21 is going to be 0.3, then times p22, which is 0.7, and then I will still have the same answer as 0.33. Okay, this thing I've done here is going to help us in the next chapter of proving the Chapman-Kolmogorov theorem. And this Chapman-Kolmogorov theorem is going to help us answer such questions which have n-step transition probabilities. But also to simplify the work more, I can also give you another hint on how we can find the transition probability. Now, since we've got what I've done here, now just put off this and then see the other approach I can do to get the n-step transition probability. Now, since I'm seeing that I'm coming, this is our Pij, the distance is 2. I'm saying that the any steps, the time difference between x2 and x0 is 2, because x2 minus 0 is going to be this one. I have Pi2j, but remember now this is the same as having p. I'm coming from 2 to 1, then in 2 times steps ends 2. Now this calls for what? This calls that I need to square my transition probability. I need to get p squared. Then I read off the 2 1 entries of that matrix. Are we together? Yes. I'm coming again. I'm saying that I have Pij, but we have 2 time steps in between x2 and x0. Yes. Us having 2 time steps between x0 and x2 and x0, therefore means I will have a 2 here up. My n is going to be 2. But now our I is saying that my current space is 2, my j is 1, and then I have a 2 here. This tells me that I just need to square the transition probability matrix P. Then I read off the 2 1 matrix there, and then I will be able to find my answer. Are we together? I think we are together. Yes. Now if we are together, try to square your matrix there, and you see the values you get. If I get my calculator, in order for me to square, I need to have a calculator, and I square. Now, let us square together. If this is my Pij, if my P is 0.4, 0.6, and then 0.3, and then 0.7 times, I'm squaring times 0.4, 0.6, 0.3, then 0.7. Yes. What I do, I say row by column. I'm squaring row by column. So times 0.4 times 0.4, I have 0.4 squared. Plus 0.6 times 0.3 plus 0.6 into 0.3. I'll have my answer as 0.34. Now 0.4 times this one, I'll have 0.4 into 0.6. Yes. Then plus 0.6 into 0.7. I'll have 0.66 as my square matrix. Then I'll have now 0.3 times 0.4 plus 0.7 times 0.3. I'll have my 0.33 here, and then I'll now need to know that 0.3 into 0.6 plus 0.7 into 0.7. Then I'll have 0.67. Then my task now is reading my value of 2 1. I'm transiting from 2 to 1. 2 to 1 is this value here, and then I'll just say that probability of x2 equal to 1 given x not equaling to 2, the same as having 0.33. And then this is the same answer we had as here. Now I think this is becoming more simple and interesting. What I have to do is just me to look for, if I'm transiting from 2 to 1, and I have n steps, like my n is 2, I just need to square the transition probability matrix, then I read off the 2, 1. And if if we had our 3 states, therefore have a 3 by 3 matrix. Therefore, if I'm transiting from state, like if my n steps are like 5 steps, I just get p power 5, then I look at where I'm coming from. If it is 2 to 5, then I just read that same matrix. Okay, an example that if let us say an example that this could be 5. If you had it like 5 here, what could we do? If we had a 5 there, what we could do is just that getting our n is going to be 5 minus 0 is going to be 5 here. Then we just need to have the p power 5 here. Yes, our n is 5, and then 5 here. And what I need to know is just now having p power 5, then I read off the 2, 1 matrix, which is 0.33. After I get this value here. I think for this step, I've tried to explain more about it. Now let us see our Chapman-Kolmogorov theorem. Yes, members, let us continue. We say that we shall just need to prove the Chapman-Kolmogorov equation. We just need to explain this more relating to the past example I've been doing. Now, from here, we say that our PI is the same as having probability of xn equal to j, x not equal to I, that the future, so the present is I, given the future is j, but they have n steps in between them, and n minus 0 is n, they have n steps. I have my n here. Yes. I think I explained that more, but now we need to expand this. This means that I will sum from k equaling to 1 up to, take an example, I have m steps, because you say that our S should contain a finite number of states, 0, 1, sorry, you said 1, our states can be 1, 2 up to m, we have m steps, 1, 2 up to m steps, n states. Take an example, we have m steps, m states, we shall have now probability of xn equaling to j. Now, given our present is xn minus 1, it has to be equal to k, because I think from the previous example we saw that our xn, our present is one which is changing always. I'm not sure again. Now times probability of now xn equaling to 1 equaling to k, given x naught equaling to I. Okay, for this past example we have been doing, the past example we had, it was probability. You said probability of x2 equaling to 1, given x x not equaling to 1. So this is the same thing as having summation from k equaling to 1, because we had 2 states. K is 1. We had 2 states. K is 1 and 2. Now times probability of x2 equaling to 1, given now x1 equaling to k, because we said so that this x1 can take on either 1 or 2. But now here we have m states. They can take on different values of k, starting from 1 up to m. Now times probability of x1 equaling to k, and then given x0 equaling to 1. I think from this step here, can you get this step here? What is changing is that our states are changing from 2 to m states now. Therefore, what we have to do is just go ahead and say, but now this is the same thing as having, now from here, this is the same thing as having summation from k equaling to 1 up to m. But remember, these are our states. Now this is the same as having probability of, now I'm coming from k to j, like that, k to j. Now times probability of us coming from k to j. But what's the difference between these two? The difference is going to be n minus 1. It's going to be, the difference is going to be 1. It's going to be Pij, the difference of 1. Our n is going to be 1, because the difference between n and n minus 1 is going to be just 1. And then I'm coming from I. I, then k. So the difference between here and this one is going to be n minus 1. Therefore, our Chapman-Kolmogorov equation helps us to find the n-step transition probabilities given any root. Like an example we can take here is that we may say Ig. Now this is the equation. This is what we want from the equation. Now from our example of what of weather forecasting, we say that let us get to know that what will happen. What's the probability of on the fourth day raining given x naught equaling to 2. We want to know the probability that on the fourth day to rain given x naught is 2. Now what you have to know is that we need to know just what we have to know. We have to know the difference between, therefore, from this step you just know that summation for now k equaling to 1. What is how many steps do we have? We have only 2 states, raining and not raining. From k equal to 1 up to 2. Now from p. Now pk. K takes on any different value, but j is 1. K1. Our j is 1. Our feature is 1. And then the difference here is just power 1. Now we shall also multiply times p. Now we are coming. Now remember, now we are coming from. We are coming from I. Our I is 2. Our pressure is 2. Now the K again here. But now what's the also n minus 1? Our n is 4 minus 0 is 4. Then this is going to be 3. Therefore, I need to get that my answer is going to be the same as having, yes, let us see, summation. Okay, if K is 1, I'll have P11 times P21, but cubed, yes. Now plus when K is 2, I need to know that this is the same thing as having when K is 2, I have P21 times P22, but when this one is cubed. Now the answer I get here is going to be my answer for this probability here. I'm getting. Like now, as we say that this P cubed 21, I need to tube the transition probability matrix. After tubing it, then I read off the 2-1 matrix and then the 2-2 matrix from here. I'm saying that we need to tube. Let us first tube and see. Remember, we had our p squared as this one. Therefore, if I have the square, if I have p squared, I can use the times p. I can get the p cubed. Therefore, what I need to know, just multiply the square times the p. If I have 0.34, then 0.66, and then 0.33, and then 0.67, like this, times the 0.4, then 0.6, and then 0.3, then 0.7, I can get my cube matrix. How is it going to be? It's going to be 0.334 times 0.4, yes, plus row by column plus 0.66 into 0.3, just like that. I'll have my value as 0. Yes, members, let us continue with our subheading. One, I want to see the n step state space probability. Now, under this chapter, under this subheading, we want to know, shall answer questions like, what's the probability that on any day it will rain? We have no conditions on this question. Like, you ask the question, what's the probability that on the 10th day it will rain? Or what's the probability that on the second day it will rain? We have nothing like condition. We've seen 3 categories. The first category was the probability of a path. Yes. Another category was the probability now of the n step transition probability. We are given the present day and the future, but we have n steps in between them. And then now here we want to say the n state space probability, where we just need to get the probability of the 10 states which brain, not given any condition. Now, for us to answer this question, you just need to know that the probability that on the 10th day it will rain, and probability on the second day it will rain. These are two different questions. Now, what we need to know that our questions will be in this format: that the probability of the future equal to j. This is the same thing as having pi. Okay, instead of us writing probability of the future equal to j, just the same as having the pi j power n, and then this n is the time space. Okay, is the time. Okay, I think is the time in which the future is, as in the 10th day. If it is x10, here I have now pi j10. And then first get the pi j10, I'm saying this pi j means the probability of the future being equal to j. We just need to get the transpose of the pi naught. This pi naught means the probability matrix of the states, as in the state of raining and not raining. Here we have 2 states now in our example. Remember, so just talking about the example of the weather forecasting. We had only 2 states. States were 1 and 2. Therefore, our pi naught means the probability, the transitional probability matrix of the states, i.e., probability of raining and probability of not raining. Then times now the pij power n, and then this n is going to be the n here. If we're talking about x10, shall have p power 10. And then if you multiply these two, I just read off the jth entry, as in, if I'm talking about the future equal to 1, now here just read off the first entry, like entry 1. Okay, let us do an example here to see what we are saying. Let's begin with probability of x. I think probability of x2 equal to 1. This is the same thing as having probability of x equal to 1. It's the same thing as having pi j. J is 1 because our future has to be raining. Is raining, and then the number of time intervals is going to be 2 here. This is the same thing as having the initial probability pi naught the transpose times p power. Now instead of n, I put this is the transpose. This is the transpose. Then instead of having n here, I put there a 2. But now I'll read off the first value, as in the first entry 1. Now, but remember, our pi naught is what? It's going to be the probability of the states, probability of it raining and the probability of not raining. But we know that this is the same thing as having 0.1 and 0.9, since we have this information in our first question. Therefore, I just need the transpose. Therefore, this is the same thing as having the transpose is going to be 0.1, then 0.9, yes, times now the probability p squared. Our p squared, we got it as 0.34, and then 0.66, then 0.33, and then 0.67. Now, if we multiply these two, we have to get our answer here. Then if we get our answer, you just need to read the first entry of that matrix. Yes. Now from there, just multiply, have 0.1. Now you're saying this is a 1 by 2, and then this is a 2 by 2. Therefore, we have a 1 by 2 again. So have our 1 by 2 matrix here as our answer. It should be a 1 by 2. Therefore, if we have a 1 by 2, we can easily now read off the first element, the first entry, which is 1 here. Therefore, let me multiply 0.1 into 0.34. Yes. Now plus 0.9 into 0.66. Yes. I get my answer as 0.628, like that. Now I also do, sorry, I'm doing row by column. Sorry, this is not the right answer. It is 0.1 into 0.34. Yes. now plus 0.9 into 0.33. You get my answer as 0.33331, and then my answer, another answer here, I'm going to get 0.1 into 0.66 plus 0.9 into 0.67, and then I have to get 0.669. If I add these two, I have to get a 1. Therefore, but my answer, I just need the pi 1. I want to do this first, but therefore, my probability of x2 equaling to 1 is going to be the same as having 0.331. Okay, now take an example. If it was now, for answering this question here, x10. Therefore, I just need to say that now if x10 equaling to 1, I just need to say that this now go to be 10, and then I put now a 10 here. Therefore, what I need to have, I need to multiply my p. My p I need to take it power 10. And if I get the power 10, then I multiply it times the transpose of our state probabilities pi naught. Then I read off the first entry here. Therefore, I think with this we can easily answer every question about the n-step state space probabilities. Now I think, members, this video is too long, but I think you are appreciating what I'm doing. And now I think I'm going to make a video with a sample question to see how we answer these following questions in our next video. Members, thank you for watching. Thank you for being patient with me. And I think you are enjoying. Members, keep enjoying. Feel free to ask any questions in the comment section. I'll be able to answer. And feel free to share the link to other friends so as they can also enjoy. Also today, I take this opportunity to thank people who are helping me. Nanaja Christine, thank you for the work you are doing. People like Jeremiah, I thank you for the work you are doing. People like Misha Regan, people like Bajenzri, members, all of you, thank you for what you are doing. I think we are still enjoying this part of the Markov chains. But now, our next video, we shall just need to have a sample question, and we see how we apply all the things we have been learning into this video. Thank you for watching. Like, subscribe, share, and comment for more videos like this.